She's a smooth operator. Hello, 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 hello. We are live. Today is January 27th, 2025. Back again, once again. Every day is a study day. And we're learning some Python. Back again into data structures and algorithms in Python. Well, thank you, everybody, for joining me this evening. Let's get some people in here. Let's let some people roll up. Hey Marty1661, how's it going? Welcome, welcome. Welcome in, how's it going? Oh, we got the Discord rolling up here. Let's see. All right, people are rolling in here. Nice, 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 nice. Hey Wing Hong, how's it going? We're going to warm up with 5 pages of note taking out of DSA and Python here. We are almost done with the trees chapter. It was a 50-page chapter, so it has taken us some time to get through. Just in its own, the trees have been pretty dense. I've been trying to just take it 5 pages at a time when it gets really dense, because I noticed that me personally, I start to lack in my note taking after about 5-10 pages. It just starts to fall off. And so if I want to keep my note taking up to par, and I want to keep my practice, my understanding, I think just keeping it at 5. We're not in any rush to get through it or anything. The information's always going to be there. So it's 5 pages at a time is perfectly fine by me. We're doing other things as well, so not a big deal. Hey, is it Lytle or is it Idle? I think it's Lytle. Hey, how's it going? Welcome in. I appreciate you stopping in. That's a new name I haven't heard before in the chat. Appreciate you joining me. How's it going? Welcome. What brings you in? Hey, Mar. Good. Always get you note from you daily. I'm a high school student. Awesome. Well, I appreciate you coming in. I honestly don't. Part of me, but I don't recognize the name in the chat. So appreciate you being able to jump in today and talk with me. You studying computer science yourself? Are you interested in it? All right, let's get started in here. All right, so we're on 8.4.6, which is Euler's tours and the template method pattern. Okay, so the various applications described in section 8.4.5 demonstrate the great power of recursive tree traversals. Unfortunately, they also show the specific implementations of the pre-order and post-order methods of our tree class. In the in-order method of the binary tree class are not general, or the in-order method of the binary tree class are not general enough to capture the range of computations we desire. In some cases, we need more of a blending of approaches with initial work performed before recurring on subtrees. Additionally, additional work performed after those recursions, and in case of a binary tree, work performed between two possible recursions. Therefore, in some contexts, it was important to know the depth of a position, or the complete path from the root to that position, or to return information from one level of the recursion to another. For each call of the previous applications, we were able to develop a custom implementation to properly adapt the recursive ideas, but the great principles of the object-oriented programming introduced in section 2.11 include adaptability and reusability. Okay, so just talking about how recursion kind of can limit you with operations, bounding. You can't really perform distinct operations at certain depths. Is what it was kind of talking about. So in this section, we develop a more general framework for implementing tree traversals based on a common concept known as the Euler-Tour traversal. Okay, so this is the Euler-Tour traversal. The Euler-Tour, gosh, the Euler-Tour traversal of a general. I dare you guys to say Euler-Tour traversal. Euler-Tour traversal 3 times fast. Of a general tree T can be informally defined as a quote walk around to the T. Okay, so you rocking around the T. Okay, that kind of makes sense by this image. You're kind of hovering around the objects like tracing the tree itself, right? Um, where we start by going from the root. Um, so I'll get a better definition from the Almighty Orb. Um, we start by going from the root towards its leftmost child. So we start going from the left, viewing the edges of a T of the tree as being walls that are always kept to our left. Okay, so you have to kind of envision this, that you are walking this direction. So your vision is pointed downward this way. So if that's the case, think about this, you got to think about this, creatively. You're walking down with your vision pointing that way. So the wall of the tree is always on your left side. You're rounding corners of the tree on your left. Okay, got you. The complexity of the walk is ON because it progresses exactly 2 times along each of the n-1 edges of the tree, once going down towards the downward along the edge, and later going upward along the edge. Because you do travel on the same edge, downward and then upward at some point. So the complexity of the walk is O of n because it progresses exactly 2 times along each of the n-1 edges of the tree. 2 times okay, going upwards and later. To unify the concept of the pre-order and post-order traversals, we can think of there being 2 notable visits to each position P. A pre-visit occurs when first reaching the position, that is, when the walk passes immediately left of the node in our visualization, and a post-visit occurs when the walk later proceeds upward from that position, that is, when the walk passes to the right of the node in our visualization. Okay, so interesting. So what's happening here is a traversal for a general tree that can be informally defined as a walk around the tree. So starting from the root, the edges from node to node always reside on the left these walls are always kept to our left during our walk. Interesting. All right, we got a lot of chats here. Hello, guys. Thanks for stopping in and hanging out with me for a second. Euler is pronounced Euler. Euler. Oh, Euler. Sorry, man. My bad. Euler. All right. Thank you for that help. Hey, Sujan. How's it going? And hopefully I said that right. Is it Suhan or Sujan? Is the J silent or is it an H? I'm not sure. Let me know. Oh, hey, Michael, how you doing? I'm actually General Talks. Oh, hey, how's it going, General Talks? Welcome back. Did you change your name or are you on a different account? Yeah, Euler, 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 Euler? Is that how it pronounce it? Euler. Okay. Hey, Tim, how's it going? Welcome back. I've been pronouncing Euler wrong my entire whole life, apparently. Yeah, me too, for the last 5 minutes, I guess. Left during our walk. I think that this screenshot, I want to just do a window. Can I trim? I want to take this. This is a really good image for the notes. So bear with me, you guys. Just want to make sure you guys who are following the notes are able to just easily kind of the whole note. The point of the notes here. This book is pretty has a lot of jargon, and so the notes can help kind of break things down to more simpler terms. So let's capture this. Let's copy the image, and can we just paste it right in here? Aha, interesting. Now what happens if we view this? Oh, awesome. Sweet. So we'll go up and say example like this, and then we'll bring this down and indent. Oh, you can't. You have to keep it like that. Nice. Is Euler the same as Euler? Euler? How's it going? You can actually say anything. Uh, it's actually a different account. Just subscribe. The way too many people on the account. It's boring to choose and unsubscribe. So no worries. Awesome. Welcome back, you guys. For those that are new here, my name is Michael. Thanks so much for joining me. I just turned 26 a couple of days ago. So, yeah, I got a lot of birthday wishes from you guys, which was so thank you so much. And thank you for also hitting our goal of 1K before my B day. It was just such a pleasure and such an honor that you guys are, hanging out with me and spending time with me. Time is the most valuable thing we have, right? So, if you're choosing to hang out and, also work on yourself in the process by learning computer science and just improving your general education, then really good for you. It's awesome. That's the whole point of this. Um, so yeah, I graduated college back in 2021. I have a degree in human biology and a minor in chemistry. I currently work as a formulation chemist for a biotech company in the California Bay Area, and yeah, I've been doing that since I graduated college back in 2021, 2022. And I currently am a mid-level. I have a scientist two position is my title, I guess. And I've been teaching myself Python for about a half a year now, and we've come a long way. Creating some multiple projects thus far. Working on a currently a pretty not large but larger than what we built before project live on the stream. Currently, we're just studying, warming up with some studying, and then we'll jump into the project and some practice problems in Neat code, lean code a little bit later. But yeah, we've been studying every day here and streaming it live, tracking our progress, really trying to convey a authentic beginner approach here. I felt that there was kind of a disconnect with a lot of the people on YouTube with what it was really like to kind of learn this from a beginner's perspective. It kind of cut out and fancy edited all the actual grinding of what it was like to put your brain to this and grind through something for an hour, 2 hours, 3 hours until you got it. And I kind of saw, it might be boring to some, but for others that are going through something similar, it might be, quite relieving to see that it's other people are doing it too. So, anyways, yeah, that's kind of my spiel, and let's keep going here. So we have a couple of notes here. I'm gonna make some notes here. So, um, a pre-visit occurs when first reaching the position that is when the walk passes immediately left of the node in the example below. And then a quote. I know I could copy and paste this right, but by physically typing it out, it kind of helps you just keep the thing stick right. It's like the same thing as copy and pasting code almost. By physically typing these things out and reading it back to myself, 3 or 4 times through this process, it helps retain things, quite, drastically, than just kind of copying it once and moving forward and reading it only once. A post visit occurs when the walk later proceeds. When occurs when the walk later proceeds upward from that position. That is when the walk passes to the right of the node in the example below. Gotcha. So so right, what's this talking about is in our example here is you have a pre-visit, that initial visit when you pass it on the node's right, um, or technically I guess if the node is way is the node facing? Occurs when reaching that is when the pass is immediately left of the node in our visualization. So it's saying that the node is facing towards the root in this visualization, which I guess all things point back to the root. So we would be traversing against the grain of the node almost, and traveling to the node's left, with our left being to the node. So we would high five both left hands of the node. We would come down, right, if we were traveling on this one, and then we'd come back to it, and somewhere around, in between this position and this position, as we either, it's kind of interesting because you actually don't, it would probably be here is when you would get it. But then it looks like you kind of get back to it here. So I wonder about these little edge cases where you have, folds back to the node. What happens at these points? Um, Interesting. But then if the node's facing now, we would be on our left with the node's right hand. And so we would have our left hand to the node's right hand. Okay. Hey, Abdulaziz. Appreciate you coming in. Sorry for if I butchered that pronunciation. Please correct me if I said that wrong. Thank you for coming in and leaving a comment here. We're just reading data structures and algorithms in Python. For those that are new here, I am reading DSA in Python. We're on page 342 of this book. We've been reading it live, word for word, line by line, example by example. Really trying to break it down. Using AI to help when possible, but also taking some detailed notes. I do like reading out of books. I think it's quite helpful. Videos are helpful, but books really have like that key, inside knowledge almost that I think videos are really pass over. Like I think that there's going to be a dynamic shift back to physical media like books, magazines, and stuff, just because of the connection that I don't know. It's just I like it. It just makes it kind of a chill environment and anyways, but yeah, so if you're also new, if you're a new programmer here, similar to myself, I started with Harvard CS50P and also read Python Crash Course live on this channel. We read all of part one live and did all the examples. I'm currently going back through and uploading solutions to the in-text problems of this book. But this book really helped kickstart my knowledge and help fill in the gaps that were left behind in CS50P. I use this book heavily when building my final project in CS50P with managing lists and finally figuring out about indexing and the importance of that and and how often it is used, and it's really helped to have something physically to go back to and reference over and over again. So I have, by the way, I have these books, everything you see on my screen from my notes on my GitHub, but also in my Discord link below, completely for free. I have over 300 people so far that have joined the Discord that are chat, ask questions daily. I respond, daily on there. I'm in there all the time, on my breaks at work. I'm a chemist and stuff. So, but yeah, the books and everything are kind of like a guide of what I've done so far in my Discord. Hey John, how's it going? Committed to the daily grind. Yeah, we are. We can't. We're not stopping here. Um, I do have some news. Unfortunate for about a few weeks down the road where I will be taking. I have to take a vacation. And I'll be kind of um, unable to stream. So I'm gonna have to figure something out. I don't know. I'm gonna have to get creative. I don't know. Um, but I know also, vacations are, it's good to take breaks and reward yourself for a lot of hard work and studying, which we have been doing on the stream. So maybe it would be time to kind of take a break and then restart the old, the counter, right, for the stream streak. So it's good in moderation, everything. So it might be a good time to actually take like a little bit of a step away, and maybe we'll come back even stronger after those few days. But we'll talk about that later. I don't want to think about that. Okay, let's keep going here. The process of an Euler tour can be easily be viewed recursively. In between the pre-visit and post-visit of a given position, we will be we will be a recursive tour of each of its subtrees. Looking at figure 8.21 as an example, there is a contiguous portion of the entire tour that is left that itself that is itself an Euler tour of the subtree of the node with its element backslash. Yeah, so or forward slash, sorry. So it's saying that in this example, there's a contiguous portion of the entire tour. You know, you have a whole nother subtree here that happens. I guess is what it's saying. The tour contains two contiguous subtours, one traversing that position's left subtree, and the other traversing that right subtree. So you even have a tour, yeah, here as well, just recursively at each depth, right? In theory. Um, Subtree. The pseudocode for an Euler tour traversal of the subtree rooted at the position P is shown in the code problem 8.7. So here's Euler tour for some tree at position P. So you give it a position so you can call recursively on that next position, right? So perform the pre-visit action for position P. For each child, right, you call on the children method of that position to get access to all the children at that position. For each child in this, next subtree, do call recursively the tour back on that child, and then perform a post-visit action. Okay. Interesting. Yeah, got you. The template method pattern. Any questions on the Euler tour traversal of a tree? Let's kind of ask the almighty Or here. Got any helpful insights or tips for a Euler tour traversal tree? Let's see what it says. Here are some helpful insights and tips for understanding and working with Euler tour traversals on trees. What is an Euler tour traversal? An Euler tour on a tree involves visiting every edge exactly twice. Once when traveling down from the parent to the child, once when traveling back upward back to the parent. This traversal is common used in LCA, lowest common ancestor problems, segment tree pre-processing, and exploring subtree properties. Key insights. This tree can be represented as an adjacent list of efficient traversal. Ensure you know the root of the tree before beginning the traversal. Result structure. During the traversal, maintain a list of visited nodes of entry times and exit times for each node. Each node appears twice in the tour, once when entering and once when exiting. Maintain a list of visited nodes of entry times and exit times. So you could use like a if it's technically first in, last out. So what kind of structure would that be? Not a stack. A stack would be first in, first out. Last in, first out. What is last in? No. Is it last in, first out? I'm getting confused. Or an explicit stack, yeah. So you'd stack that one on, stack that one on, stack that one on, and then as you get down here, you start popping them off. So it would be a recursive stack, exactly. Okay. Subtree queries, okay, so that's fine. We're not to all these crazy stuff yet. Hey Natty Santas, how's it going? Welcome. Have you tried the new Chinese AI DeepSeek? I hear it's better than. No, I haven't yet. I'm just kind of sticking with what I know here. Hey, Rock on the Rocks on Tax. How's it going? I thought it was Rock on the Rocks. How's it going? Well, thank you for the hearts. Appreciate you coming in. What's going on? And what are you guys working on? If you guys are studying alongside me, let me know. If you guys are just following along to what's going on here, or if you guys are working on your own projects or homework on the side, let me know. If are you in school? Introduce yourself. Tell me about yourself. It's we have a community kind of growing here. People have kind of become quite friendly with the people that kind of reoccurring watchers here, hangouts here. So thank you guys. Let me know what you guys are up to. Because the stream not only can be just what I'm studying here, but you can just use it as an accountability thing. I'm holding myself accountable here, streaming, making myself study every day. So if you're wanting to do the same, then you could throw on the stream in the background and just kind of hang out here and work on whatever you're working on. And then when it's over, that we can just be done and just use that as a way to also study along with whatever you're doing. Okay, so the template method pattern. Here we go. The template method pattern. To provide a framework that is reusable and adaptable, we rely on an interesting object-oriented software design pattern, the template method pattern. The template method pattern describes a generic computation of mechanism that can be specialized. See, this is what I'm talking about. It throws you this jargon. Can we not? Why do we have to speak so technical? Why can't we just try to make things simple? The template method pattern describes a generic computation, so a generic calculation of some sort, mechanism that can be specialized for a particular application by redefining certain steps. Come on, author. Who are you talking to? Who are you talking to here? Come on. To allow customization, the primary algorithm calls auxiliary functions known as hooks as designated steps of the process. To allow customization, the primary algorithm calls auxiliary functions known as hooks. Okay, so you can call like QuickTime events, I guess, with hooks. Like, oh, press A, hook. In the context of an Euler-Tour traversal, we define two separate hooks. A pre-visit hook that is called before the subtrees are traversed, and a post-visit hook that is called after the completion of the subtree traversals. Our implementation will take the form of an Euler-Tour class that manages the process and defines trivial definitions for the hooks that do nothing. The traversal can be customized by defining a subclass of Euler-Tour and overriding one or both hooks to provide specialized behavior. Bruh. Let's go like this. Let's say, can you please break this down? All right, let's break this down. What is the template method pattern? The template method pattern is an object-oriented design pattern that provides a generic algorithm structure in a base class, while allowing subclasses to customize specific algorithms. Okay, why couldn't it have just said that? So, an OOP design pattern that provides a generic algorithm in a base class. Right. While allowing subclasses to customize specific steps of the algorithm, right? Algorithm. It's like having a recipe with a basic structure, but you can tweak certain ingredients or steps to suit your needs. Nice breakdown. Key concepts in the description. Generic computation mechanisms. The base class defines the skeleton of an algorithm. So, like an abstract. So, what's the difference between this and an abstract base class? It has a series of steps that are meant to be followed. Specialization for a particular application. Subclasses or derived classes customize specific steps of the algorithm by overriding certain methods. Hooks auxiliary functions. Um, so let's do something here called hooks. So these bad boys are these are customizable methods or placeholders in the base class. Customizable. Was it? Is there an E in customizable? No. Oh, methods or placeholders in the base class. The base class calls these hooks at specific points in the algorithm. Subclasses can either redefine these hooks or implement custom behaviors to them. Hooks are called at specific points can be customized. Right? Right, Tim Skyhook. Hey, Toast Dev, how's it going? Welcome in. How's it you doing? Long time no see. How's it been? You been back in class? I think you mentioned you were back in school. If I'm wrong, I apologize. But thank you for coming back in and stopping and saying hello. Brayon says, I'm doing leak code. Gotcha. We'll get there eventually. Watching YouTube stream. Awesome. Awesome, John. Edith said, I'm getting a website out for my compliance purposes at my company. I'm a DevOps engineer, failed out of school, senior year of college. If I can do it, y'all can too, even though I don't know data structures. No worries. And thank you so much for coming in and for those kind words. Appreciate you coming in and leaving a message. Yeah, definitely. Using the AI to help us for sure. I'm lost on template method patterns. So a subclass can change the algo. Yeah, so it's basically saying like it's kind of like similar to an abstract base class, I guess, like in theory, an object oriented design program pattern, right? Um, for a general algorithm of the base class, and then maybe that there's specific algorithms that you can do to instead of multiply, you divide. I'm not sure, right? Because that's the example it gave in this picture, right? Here. In this picture, right, it does multiple operations. So maybe what you could do is like call certain hook functions to flip these signs to their opposite operation. So you could call a hook to flip all if whatever, like to flip sign, like a hook something. I don't know, could be an example. That's just something off the top of my head. I'm not sure. Okay, base class. How does it work? Base class. Define the overall structure of the algorithm, the template method. So you define the overall structure of the algorithm with a base class, and then you have a sub method that has methods for each step of the process, some of which are abstract or hooks for customization. Then a subclass inherits from the base class, implements or overrides specific steps, the hooks, to specialize the algorithm. Right? Because let's say that the base class has a hook on it that you don't want to use at that point, and it has a hook baked in at step, sub-step B of the recursion. Well, if I want to instead multiply instead of divide, I could make a subclass of this base class, instead of inheriting that hook, I could then override it. I think they're just saying hook as a way of saying it's the same thing as saying like a class method almost, or like an instance method, right? You can call a hook or some sort of function to over in the subclass and override that method in the base class to do some sort of different operation. Yeah, Joseph, right? Isn't that crazy? Been killing it. Definitely 200 of 1.07, right? We're almost to 1.1, and we just crossed 1,000 a few days ago. So honestly, it's really thank you to you guys truly for supporting me day in and day out, and also just supporting yourselves. This is really about also you be selfish in this. You're learning for yourself as well, alongside me. So uh, this is just as much about me as it is you guys here too. So thank you guys truly. Um, Edwards 404. I'm studying for Noster. What is the Noster? Sorry. Specific on how to create a video platform like YouTube. Oh, okay. Interesting. This chapter just jumped up in difficulty by a lot for me. Yeah, this one was a little bit tricky. Like I said, this one was like 50 pages long, so it was really dense. That's why we're taking it kind of slow. Hey Levi, welcome in. How's it going? I do not know much about automation. I've thought about picking up the Automate the Boring Stuff book, that's kind of like the sister or whatever of this book, but I'm not sure if it's kind of um, I'm not sure if it's. I'll have to look into it. Maybe I don't want to go back in words and keep learning about lists and stuff again when we kind of already passed that. So I was just, what do you guys think? If any of you guys have used that book, is it too kind of beginner? I know this is the beginner channel, but is it too like this is the first thing you should read? All right, let's keep going here. Um, in the context of an Euler-Tour traversal, we define two separate hooks, right? In this example here, they have a hook here, perform some action at the pre-visit and perform some action at the post-visit. So you could call a subclass of this Euler-Tour class to, instead of having some sort of action that's by default happens here, like, oh, take the length at this point, or do some sort of math operation. No, well, I can customize it by making a subclass of Euler-Tour algorithm, or right, and then the algorithm itself, which is housed in a class, right, and then override whatever is being called here by just kind of recoding it. Honestly, redefining it. So we define two separate hooks: the pre-visit and the post-visit. Um, Our implementation will take the form of a Euler-Tour class that manages the process and defines trivial definitions for the hooks that do nothing. The traversal can be customized by defining a subclass of the Euler-Tour and overriding one or both hooks to provide specialized behavior. Cool. Python implementation. Our implementation of an Euler-Tour class is provided in code fragment 8.28. The primary recursive process is defined in the non-public underscore tour method. A tour instance is created by sending a reference to a specific tree. So a tour instance is created underscore tour. So here, tour is created. Is called. Where is tour called? Here on an execute function on the root of the tree. Um, the primary recursive process defined in non-public. The tour is created by sending a reference to a specific tree to the constructor, and then by calling the public execute method, which beings the tour, which beings the tour, should begins the tour and returns a final result of the computation. So we have the Euler-Tour abstract, an abstract base class. Yeah, so it is an ABC, like what we talked about, right? So this is similar to an abstract base class, an ABC. So you have an abstract base class for performing an Euler-Tour of a tree. You have a hook pre-visit and a hook post-visit that may be overridden by a subclass. So on initialization of the object itself, given some certain tree, Prepare an Euler tour given a template for a given tree. Okay, so we just redefine under self tree. Okay, that's how we can access it with the non-public tree method. Um, or what they put in the template. So when we define tree, you return self.tree. Return a reference to the tree being traversed. Okay. On execute, if the length is greater than 0 of the tree, meaning that we have nodes to visit, we return a call to self.tour of the root at, so the path, the position would be the root, the depth would be 0, and the path is a blank list. Okay, got you. So you perform a tour of a subtree root at position P. You have P is the position of the current node, which is when it initializes the root, right? Depth of that tree is 0, so I'm guessing you're going to count somewhere, you know. And then you have a path, the list of indices of children on the path from root to P. List of indices of children on path. Okay, so then we won't get too into the woods. We're almost done with this portion here, but let's keep going here. So you have a self-hook pre-visit. So this is the pre-visit that can be overridden. Given some position, a depth, and a path. Results is some empty array. We append the path to position 0 in the result into path here given. No, you just append 0 onto path. Add a new index to the end of the path before recursion. Oh, because you need to start it. So remember, the path is an empty list here on the tour. Okay. So you give it the root position to pretty much start as your path, you're following basically. For children in the children at that position, you append to the results array a recursive call on the child root position, depth +1 each time with the path. Okay, and then increment the index path. The last path goes up by 1. Okay. Oh, I got you, because you become index 1. It's from 0 because you appended 0 here. Then you still have a variable answer here, which is post visit, and you return that answer on the post visit. Pass. So you can override these functions. Gotcha. All right. Get caught up in some chats here. Thank you guys so much for joining me. If you're enjoying the stream so far, feel free, if you would be so kind and are inclined to, and enjoying hanging out with me, leave it a like. And if you enjoy the overall process, consider following along. The channel has been growing, and it just is kind of proof, though, that this process is working, because I started from not knowing what a single function was, or what a single line of code was. I just had a background in physical science because I have a degree in human biology and a minor in chemistry. I graduated back in 2021. I work as a chemist, for those that are new. And I've been teaching myself just, after my 9 to 5 job every day. So it's been a slow grind here, but it is working. We have learned a lot and been able to make some projects, and I'm able to, I can feel myself starting to get faster at things, and it's really, really cool. Hey, Hiran Patel, welcome. Try Visual Algo, help me understand it. Awesome. Yeah, I'll have to give that a try. Consider joining the Discord and putting a link to it so I can have a reference to it after the stream, Hiran. Appreciate that suggestion. Um, I will say, Toast Dev, we are kind of almost through with the chapter here. The chapter ends on page like 50, so this is coming to the end. So the introduction was about 30 pages ago. So if you want to revisit that, I highly suggest taking a look at the beginning of the chapter. At least from my understanding, now this isn't, I just have been following this process consistently as I've been reading here. I kind of am following along with what's going on here. But I've also just used trees naturally in science with, like, evolutionary trees and all that stuff. So it, it it's not too unfamiliar. Okay, so we got a couple pages left here. Okay, based on our experience of customizing traversals for sample applications, section 8.4.5, we built support into the primary Euler tour for maintaining the recursive depth and the representation for the recursive path through a tree. Using the approach that we introduced in code fragment 8.2.8.24, we also provide a mechanism for one recursive level to return a value to another when post-processing. Formally, our framework relies on the following two hooks that can be specialized. Method underscore hook underscore pre-visit at a position with the depth given a path. This function is called once for each position immediately before its subtrees, if any, are traversed. Parameter p is a position in the tree, d is the depth of that position, and path is a list of indices using the convention described in the discussion in code fragment 8.24. No return values expected from this function. Method hook post visit, given some position, depth, path, and some results. This function is called once for each position immediately after its subtrees, if any, are traversed. The first three parameters are use the same convention as did hook pre-visit. The final parameter is a list of objects that were provided as a return values from the post visits of the respective subtrees of P. Any value returned by this call will be available to our parent of P during its post visit. For more complex tasks, subtrees of the Euler tour may also choose to initialize and maintain additional state in the form of instance variables that can be accessed within the bodies of the hooks. Using the Euler tour framework. To demonstrate the flexibility of our Euler tour framework, we revisit the example applications in section 845. As a simple example, an indented pre-order traversal akin to that originally produced in code fragment 823 can be generated with the simple subclass given in code fragment 829, where we have a class pre-order print indented tour, given some Euler tour as a subclass. So our hook pre-visit, we're overriding it here, right? So in Hong, this is what we're doing is we're overriding the Euler tour here with a subclass, and we're overriding the hook pre-visit to do some printing of the subclass at this current recursive step. So a subclass of the Euler tour that produces an indented preorder of its tree's elements. A tour would be starting by creating an instance of the subclasses for a given tree T and invoking its execute method. This could be expressed as follows. Tour equals preorder print indented tour T, tour.execute. All right. Let's just read this last page because we're almost to this section heading here. Last page here, and we'll move on to a different topic, guys. Thanks for sticking with me here. A labeled version of an indented preorder presentation akin to code fragment 824 could be generated by the new subclass of the Euler tour shown in code fragment 830. Class preorder print indented labeled tour of the Euler tour. So this is just that subclass, preorder print, right? On the post visit. Interesting. So you join the depth, 2 times depth. You print the 2 times the depth, space plus the label, and the element. A subclass that produces a labeled and indentation preorder. Yeah. To produce the parenthetic string representation originally achieved in code fragment 825, we define a subclass that overrides both the pre-visit and post-visit hooks. Our new implementation is given in code fragment 831. So this is just a callback of actually implementing that parenthetic representation of trees, right, using parentheses. Notice that this implementation we need to invoke a method of the tree instance that is being traversed within the hooks. So in the hook, we call is not tree. If is not tree is if self.tree is leaf at position is not. So okay. The public tree method of the Euler tour class serves as an accessor for that tree. Gotcha. Finally, the task of computing disk space as originally implemented in code fragment 826 can be performed quite easily with the Euler tour subclass shown in code fragment 832. The post-visit result of the root will be returned by the call execute. So disk space tour. So these are just callbacks to actually implementing these with the Euler tour class. Okay, cool. So this will be a good place to stop on 346. So we have um, only, oh, we're almost done. So we're almost only, 5 pages. So tomorrow we'll finish the chapter and then we'll move on to some tree practice problems. But actually, guys, we are a little bit been bad. We haven't finished chapter 7 linked list practice problems yet. So we do need to go back and finish some of these, I think, before we move on and continue on through chapter 8 practice problems. So we need to keep up here. We don't want to get behind. But I wanted to keep reading because this chapter was long, so that's why I wanted to just keep going. But hey, Insomniac, welcome in. How's it going? I think I already said hello, but welcome in. um, Hooks are just added complexity to the flow of the process and change the behavior of the OS apps, etc. Where do you have this PDF at? I'm in Discord. I'm starting to refresh linear algebra, getting stuck on Python data structures. Yeah, it's in the Discord here. Let me pull it up. So it's going to be just in the Python section in DSA in Python, right here. Data structures, algorithms in Python PDF provided here. You can hit it with a reaction if you enjoy it. Also, this is the live GitHub that you see on the left hand of my stream right now. So I have a GitHub um, uh, link here, which is just this repo that you see right here, which has all my practice problems from 7 all the way to the beginning of the course. So over like 100 practice problems going over DSA and Python thus far. My personal answers to them. Hopefully they're right. But yeah, it's in the Python category. Cool. All right, so let's go ahead and should we take a stab at a LeetCode problem? What do you guys think? Let's get some zeros for no, ones for yes in chat. Zeros for no, ones for yes. Yes on LeetCode. Let's go, yeah, yes on LeetCode for 1, 0 on for a Leet. No, I'll be right back. I'm going to get some lemonade. All right, guys, I'm back. got a snack, got lemonade. We're good to go. All right. Redo that one from the other day. See if we can do it quickly. Which one was that one? Do you remember? Do you remember? All right, let me load up here. Neet code. Let me sign in here. Should we do leet code or neat code? What do you guys think? All right. Neat code, okay. Let's go roadmap here. All right. Oh boy. Oh boy, oh boy. Should we... Easy. Implement sorting, insertion sort. Should we do insertion sort? I think this might be a fun one. We just learned about sorting in our CS50X course. So maybe we should give this one a go. It says easy, so we'll try it here. We'll allot ourselves, 30 minutes here. Okay, implement insertion sort and return intermediate states. Insertion sort is a simple sorting algorithm that builds the sorted list one element at a time from left to right. It works by repeatedly taking an element from the unsorted. Is this a leak code problem or is this a predicate? Okay, hold on. Okay, whatever. It works by repeatedly taking an element from the unsorted portion and inserting it into its correct portion in the sorted list. Objective: given a list of key value pairs. Okay, a list of key value pairs. So we have a tuple of, okay, 2 values. Given a list of key value pairs, sort the list of key by key using insertion sort. Return a list showing the state of the array after each insertion. If 2 key value pairs have the same key, maintain the relative order in the sorted list. So the thing is we not only have to account for the number, we have to take the entire tuple with it as well. So in the first output, it output just the regular array, apple, banana, cherry. And then it would swap the 2 and the 5, and then it would output the final array. Notice that the output shows the state of the array after each insertion. The last state is the final sorted array. There should be pairs.length states in total. So three, okay, relative to the length. In this example, you can observe that the pairs with key equals 3, cat and bird, maintain their relative order, illustrating the stability of the insertion sort algorithm. Oh boy. So what's going on here? We have a solution class where we have insertion sort. Given an instance itself, a pairs, which is a list, given a pair class. And a pair class is initialized with a key and a value. So is a list of lists, or I'm having a little trouble with this context. Are these individual lists, or are these, because here it's calling a list object on pair. and returns a list object of the list pair. Okay, so this one's kind of funky. I'm not really sure how to approach the tuple aspect of it. Or is it a tuple even? I'm not even sure if I use that word correctly. Um, so insertion sort, we know that we have to just loop through and have basically a left pointer and a right pointer. So left equals 0 for right in the range That's what I'm wondering. It's kind of funky, right, Wing Hong? For right in range of the length of the pairs, um, right? Okay. Yeah, it's a little funky. So we have a left pointer at index 0, and we have a right pointer starting at index 1 through the length of, up to the length of the pairs, right? So if they have 3 pairs, then we'll go start 1, 2, 1 and 2, and that meaning that, and which is 0, 1, and 2 on the right. Okay, gotcha. Perfect. So we need to basically, with insertion sort, let me pull up my whiteboard. Let's try to walk through this. I don't care if it takes us some time. I want to understand it. So we have, let's just try to get it with some elements, and we'll worry about the tuple part later, I guess. So you have some, list of x, y, and z. Now, that's not in order, though. So let's do 3, 2, 4, 1, right? So we're going to say we have left at 0. So we have index 0, 1, 2, 3 for index, right? We have left is going to start here and evaluate this number. Right is going to start here. We want to say if left is greater than right, swap left with right. Right? And then we need to increase left and increase right, basically. So if now we need to access the 0 variable we need to access the variable here or this data point to do the evaluation, though. So pair has a key and a value, so we have to access dot key. So if pair link the pairs. So how do we access the individual pairs? So it would be pairs whoa, okay, this is trippy. So how do we access the individual pairs? So we have a pair which is in a list of pairs, so we have to say the range of pairs. So access the first pair. So the left pair, if pair left if this pair dot key is greater than pairs right dot key, right? Then we need to swap them. So we need a temp variable here. Temp is going to equal pairs left right. So we can just access the entire pair left and swap it that way. So then we'll say pairs left is equal to pairs right. Pairs right is equal to pairs left. Or sorry, is equal to temp. Because we override pairs left here. So now we're successfully swapping the variable. Now in Python, we can actually just do it like this. Pairs left, pairs right is equal to pairs right, pairs left. So that's how we can do the swap that way in Python. In C, you could do it the other way though. Right, guys? I think so. You guys agreeing with what I got so far? Anybody have any disagreements? If you guys feel like I'm going down the wrong path, feel free to say something. We can work together here as a group. This can be a collaborative, process here. This isn't just, let me grab a nerd candy while we wait. These things are addictive. Okay. So we access the pair left, which will be the first index pair, which will be the first pair. We'll access the pairs right key, so which will be index 1 on the first iteration. So that'll be the second pair accessed and the key of that pair. Yeah, see, that they're trying to, I think, confuse you with this thing and try to make it, so just kind of keep it. I'm using a 2-pointer system here, right? So I'm using, this is kind of a, this kind of setup, this left equals 0 for right in range length of whatever you're iterating over, a 1 plus or like of I plus 1 or whatever. This kind of format is this typical pattern that I've been seeing over and over again in these beginner leak code problems. Okay. If anybody has any disagreements, let's speak now. Please call me out. Okay. We then can say, I don't like that. Let's go back. So that's what happens if it's greater, right? So we're first going to start off on our example here. Let's look at our example here. Let me zoom in. Our example on the left. We're going to start off on this pair here, 5 and apple. We say left is equal to 0, which is going to be this pair, and right is equal to 1, which is this pair. We say if pairs left, so pairs 0, 1 here, right here, dot key, which is this guy here. They're just kind of using this class to mimic dictionaries without actually using one. So if this key is less than or is greater than this key in pairs at 1 for the first iteration, we're going to swap those pairs with this line here. Now, a couple seconds ago, I wrote out kind of a C equivalent of using a temp variable. Okay, else, if it's greater than, so if it's greater than, do not, if it's less than, like in this case, 2 is less than 9, we wouldn't want to do anything. Now, what happens if it's equal? We want to just insert one less than right. So elif pairs left dot key is equal to pairs right dot key now we need to pop and insert in the same call. Oh, so we're inserting then. Oh, so I'm using the wrong algorithm, you guys are saying. So insertion sort then. I don't think we've learned about insertion sort. We learned about selection sort. We learned about bubble sort. We learned about merge sort. So I don't think we learned about insertion sort yet. Well, maybe we got to figure out right now. So does in Python can we use I mean, we could iterate from the back and so insertion sort means, does insertion sort just mean you grab the first object, basically do you pop the first object, find where it goes and insert it right then and there? Is that all? Is that the only difference? Yeah, is it inserting into a new array or is it in the same array? So do you pop off the element that you're currently on and then just insert it directly, use the insert? Basically, yes. Hey Ryan, what's going on? How goes your CS50X? Don't mind the crinkling and grabbing a nerd cluster here. Let's look up. Don't show me code, but describe insertion sort. Insertion sort is a simple intuitive sorting algorithm that works similar to how you might sort playing cards. Start with the first element, treat it as already sorted since it's single element, always sorted. Pick the next element, take it from the unsorted portion of the list, insert it into the... Wait. Start with the first element. Treat it as already sorted since a single element is always sorted. Pick the next element. Take it from the unsorted portion of the list, insert it into the sorted portion, compare this element with the sorted elements, starting from the back, shift larger elements to the right if you find the correct position. Shift larger elements to the right until you find the correct position for the current element. Repeat the process. Continue picking the next element from the unsorted portion. and inserting it into its correct position within the sorted part of the list. Once you've placed all elements into their correct positions, the entire list is sorted. Interesting. So, like, the return value here is you return a list of the list pair provided. So you are creating a new list object, it looks like. Oh my gosh, that was really loud. Sorry, guys. Maybe I should dump a few out so we don't have to do that. Let me dump a few of these guys out. Sorry, bear with me. Alright. Okay. So then, what do we need to do then here? We need to say, we need to take out the first element. We need to take out the first element. So we're gonna take out 3 and put it into a new list, or a sorted list, right? We're going to put the 3 in to the sorted list. We are then going to grab the 2 and put it and evaluate like while is greater than continually starting from the back. So you start from the back while 2, if it's greater than, pass, else insert at that point. So then the 2 would fall here. We start from the back, we say, oh, it's right here. When we pull the 1, start from the back, shift, 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 1. So we say sorted list is equal to a new list object, right? We then say so we just need to append the first value. So go pairs index 0 dot append. No, we don't want to do that one. We want to append that value initially to the sorted list. We also need to save the appended state of the array. Yes, so okay, so you find the length of pairs. We sort the ascending order based on the array, based on the key. So if we append the first value, because the first value is always sorted, we then say for every pair in pairs, right? We want to, for every pair in pairs, we want to call a function called So I could create like a helper function to do the check for me to kind of break things up. So for our pair in pairs, we want to, right now we have the first pair in there. Now we access the second pair, or technically now it's the first pair of the recently appended regular list. Yeah, no worries, Ryan. That sounds like a good plan. I'll be watching the lecture tomorrow. So good on you for moving on here. How are things for the coding chemist? Still recovering after Tide Man yesterday. I got a limp arm. I got a bruised eye, a bruised coccyx. You know, it was rough for me. They really did a number on me. And so, but we're recovering today. I took it easy. No, that problem was hard, man. Okay, let's keep going here. Um, Start with the initial list. We insert correct position during step 2. Start with the initial list. But find the length of pairs in order to iterate. Yeah. So for pair in the do you want to do range length of pairs? So now we can access the index values of each of them. But we would already be accessing each pair. So for every pair in the range length of pairs, like this is the same thing. Now we're just accessing um, actual. So this is the index value now for I in the range length of pair. If pair, so can we say while pair pairs index I dot key is greater than or is less than um, can we say while the pairs at index I key is less than all the so we know that the sorted list is going to have one less is one a value taken from the list pair. So how can we dynamically track the sorted list as well within our loop here? Because we are, iterating over the list of pairs here with I. So we removed a pair in our example. There's 3 pairs. So now there's one. Now there's 2 pairs and 1 pair in that one. So we'll say while so if we don't want to start, why would I thought we want to start with 1 in there because it's already going to be sorted. So instead of doing this, we could just say, but this will be a reference to that same pair, right? And if we insert the pairs index 0 directly into here, right? What is going on? If we insert this directly into here, it'll just be a reference to that element and actually not removing the element from that list pairs. So we'll just fine. We'll keep it off. You guys are suggesting to not put that one in there at first, so we won't do it. We'll say for I in range length of pairs. Someone is also suggesting to use an n value variable defined outside first. We're not constantly finding the length of pairs at each iteration of I. We're just using a constant n now created at the beginning. So we'll do that as well for memory purposes and efficiency, I guess, and timing, I guess. Um, so for I in the range of n, while pairs at index I is less than um, while pairs at, so now how can I access, so we need to have a clause here that says if sorted list, right, a Boolean expression here, we will just go sorted list append pairs but this will do it at each iteration. So we'll say if not sorted list. So if there isn't any values in the sorted list, we'll initially we'll append the first value of pairs, right? We can then say basically you're storing the second step of the array. What do you wait? Hold on. So delete. You're getting sorted list. Basically, we are storing the second step of the array. So check your for loop again. No, now we're not starting from this. I was starting from the second element when I appended that one. Now, if not sorted list, we'll start from the second element and we'll say while pairs index I dot key is less than so do we have another for loop here saying for well, yeah, it's insertion sort, so I think it's n squared in O of n time. In the best case, it's O of in big O time, it's O of n squared, I think. So I think it would be two nested for loops. So for j in we need to dynamically check at each iteration the range length of sorted list. So we need to check at each iteration, right? We can do this up front here because this doesn't change, but sorted list is going to dynamically be increasing with our new list basically. So for j in the range length of the sorted list, while I mean, we could use. Should we cheat it and use Python's insert method, or should we try to do the index increasing ourselves? I don't know. I'm not really sure how to do the index increasing ourselves. We just have to save that value as index +1 on that list. Okay, got you. Okay, so um, while sorted list. So we need to loop over the range length of sorted list. But we're starting from -1, right? We need to start from the back. And that means that the sorted length of sorted list will have to be negative sorted list, and to be exclusive we'll have to -1 from it as well, with a negative step here as well. So this might seem crazy what I'm doing, it might seem, but if you think about it, if I'm starting from -1, the last number in the sorted list, to start going backwards in this sorted list to find out where to insert this method, this number, right? It's easier than starting from the front, because once I find the number, then I'd have to insert and push all those subsequent numbers back. But if I start from the back, I can just keep increasing in n time, rather than having to kind of slice n forward, or that, whatever, if that makes sense. So if we start at -1, we want to have negative range length, because if we're -1, if the sorted list has one value, that's -1 would not be included. So we need a -1 to get to -2, so that one value is included, and then have a negative step so we go backwards. We would say while, no, if pairs index I dot key is greater than pairs index I dot key, no, not pairs index, sorry, sorted list index j dot key, right? So this is going to compare the first value, 0, in pairs with the last value in sorted pairs. So, but first we're going to immediately append this off, and then, no, but the thing is if that means that I is then going to become 1 and skip over that value that got taken off. So that's why I think we need to do the append out front. Right? I might be wrong, but I think we need to do the append out front initially, because if we do it within here, our I will continually iterate and will skip over basically that removed value. Well, does the append method remove a value or just take a reference to this value? Actually, if it's just a reference, it's fine, right? So if append, all it does is pull the reference in memory of pairs index 0 and place it into our list here, then that's fine, because our list of pairs will remain unchanged at the end of this. We're returning a new sorted list, right? Hey Mahan, how's it going? We're working on insertion sort. I've never done this before, so we're trying it out. Trying to learn it here live. All right. Okay, so okay, Toast Dev, my question was, does this append method, this is an easy. Does this append method, right? I'm trying to, I know you had mentioned that we need to not put it on the outside, but does this append method pull a reference in memory of this object and then place that in the same reference in this array, and leave pairs how it is? Or does this append also pop that method, that element, and then insert it in here. Is it what actually is happening in append? Is it popping from this list, or is it just pulling the reference in memory and placing it there, leaving the pairs list the same? So if pairs greater than, so if the pairs one, so we have the first value in there, it's apple, which is 5. We next get 2. So pairs index I key is going to be less than, so if it's less than, we need to insert if it's less than, so if it's greater than the value, it just will get appended, right? If it's greater than, we'll just go sorted list dot append pairs index I. But my question, Toast Dev, is that if we need to initially append a value, because it's going to try to access here, it's going to try to access here a value, and if it can't find a value in here, I'm going to get an index error. This is the insertion sort question, Mahan. So I have to already have a value initially started in the list. So that's why I initially had this happen out front. Right? I had this happen here because I need to have a value inside the sorted list before I begin, because I'm trying to access a key, an index inside of this list. Right? So for I in the range of n, for j in the range length -1, negative length sorted list -1, -1 step, if pairs index I dot key is greater than, we're just going to append to the end of the list. Right then and there. Right. Elif Elif but this is going to do this check at every index of I all the way through. So because we're dynamically accessing the length here, it will do it for the increased size. So if it's 0, -1, -1. -1 in here, if it's 0 initially. Yeah, that's what I had initially, John. I had if sorted list, in my iteration here. So I said if sorted list here, go ahead and sorted list out append pair 0. So you'll get this off on the first iteration, but why not just do it in the call out front here? I mean, you can keep it all within the loop if you just do that, right? But this would have to say if not sorted list, right? If it's empty, go ahead and append it. So if, right, if it's equal to dot key is equal to sorted Okay, so basically this is what we are doing. We start with the first element, then we take the second element, compare with the first element. Yeah, exactly. If it's already in the, we have to have something already in the list though to compare it to, because we're accessing this list via index. And so if this list is initially empty and we don't want to initially append just right off the bat, we have to do an evaluation to append. I'm going to leave it like this. I think we're on the right track. Yeah, right, Toasta, but 5 and apple already has to be in our sorted list in order to access it via index error. If we didn't have this and try to do this evaluation, we would get thrown an index error because we have an empty list here initially. We have to have a value initially appended into it. So if pairs index I at keys, so now we're doing the equal condition, we want to leave the order the same. So what does that mean? In this case, you have 3 bird, 3 cat. Cat came off first. So you would need to append and shift you would need to dot insert at so if you have cat and bird here, you get cat and bird back. So cat is the one that's pulled off first. Bird then does the evaluation. If it's equal to, you append, you insert at j plus 1. Yeah, you insert at j plus 1, and then you have to call so if it's equal to, is this getting even crazier to have another for loop to, we have to, I mean, we could say sorted list dot insert index j plus 1 element pairs index I. Right. So the length is going to be initially -1 or 1. So -1 minus 1 -2. What do you have to fix about it, Toast? What's wrong about it? You got to provide some sort of input if you're going to make claims. Okay. Starting from the back. So we'll insert here. Else it's less than. So you have to do sorted insert j minus 1. I'm starting from the last element because if you start from the last element and you meet this condition, you don't even need to iterate all the way through n, right? So if you have a number that is greater than, you don't have to iterate all the way through n in order to append it to make that decision. Or at least all the way through the sorted list of length of pairs minus the current iteration of n minus ith. Yeah. If pairs at index I key is greater than sorted index j dot key. So what's happening here? Let's go to our example. Let's look at our example here. We have a sorted list. We are taking a length of our pairs, which in this case is 3. Okay? We say for I in the range of 3, so 0, 1, 2. If there is not a element in the sorted list, go ahead and append pairs 0. So pairs 0 go back to what I had before with pairs 0. My question was, does append just create a reference to that object in memory and leave the pairs list or the same, or does it pop out? So we could just do that initially, right? So we say pairs is 0. So pairs is our new list or sorted list has app5 and apple in it, right? But I don't want to iterate over right. I don't want to also do that first value. So we need to say 1 to n here because we want to start on the second value, not the first value, because append this just makes a new reference to that object in memory. It stays within our pairs list though, right? From my understanding. So now we'll say, so now in our sorted list we have 5 apple, but in our pairs list we still have all of these values. So we're starting from the 1 index now to skip over that already evaluated value, right? So we're starting from bananas and 2 and bananas pair, right? And then we also say for j in the range of -1, so starting from the last value of something, last index, on the negative length of the sorted list. So if we have one value in here, we're on the negative length would be -1, right? But that is exclusive. That would not be included on the value, and we need to include that value. So we have to do a -1 here to get -2. so which is excluded, so it's negative 1, 2 up to negative 2, and we have a negative 1 step. So now we're going to do evaluation on the negative 1 of j, which is in the sorted list. So that's going to be the first or the only value in here, technically the last, they're going from the back. So it's going to evaluate 5 apple with is in sorted list with 2 banana, which is in in pairs I here. If it's greater than, we're just going to append onto the sorted list the greater value, just right to the end. It's greater than the value at that current point, starting from the back, so just append it right on. Elif, the key is equal to it, right? We insert at 1 plus j. Because we're starting from the back, we want to keep our original order. We need to go 1 place forward from that equal value and insert right there. Else, it's less than, right, by default, and so you insert 1 less than j. What I hate how all the references and stuff is hidden in Python. What do you mean the references and stuff? I am using insert item and index. But you don't need to use that here. You can just use append, because you're just appending to the end of the list. If you meet a point, oh, but I guess what you're saying is, right, you can't append here because you might get to a point where, I get what you're saying, so you have to insert here as well. This would be, if it's greater than, it would be just j plus 1. So it would be j plus 1 again, right? If it's greater than. So then we could just formulate this into a single line, like so, and get rid of this altogether. Now we have this. Oop. What? Why are you doing that? Oh, it's omega. I can't wrap. How can you wrap in this? Can you not wrap? Reset, report full screen. What do you guys think about this? Should we try it out? I mean, we're not done yet. We have to do the printing and stuff. But what do you guys think? So now we just need to do some printing. So return a list. You don't even get to a point where something is less than, it's just greater. You don't even get to a point where something is less than. So if it's less than, or what do you mean? You can just do by default. Well, is my for loop wrong, or is it just wrong in your opinion with your typical approach? I mean, is it is it right though in terms of the objective? Like, is it doing what a for loop's supposed to do, at least in this context? Okay. Okay. Looks like we got some disagreement in the chat here. Okay, so next up. But range I minus 1 to negative 1. I minus 1 up to negative 1 with the negative step. Yeah, that would work too. Ooh. I minus 1 up to negative I, which in this case would be 0. Okay, we keep getting distracted here. Objective. Return a list of lists showing the state of the array after each insertion. If return a list of lists showing the state of the array at each insertion if two key value pairs have the same key. Oh, this is interesting though, because this is what's going on here? It's like a list within a list of lists at each step. So your output, you return a list, but it looks like it sorts in place on top of itself. Oh, so do we not use a sorted list? Because it looks like it outputs the current array onto itself. Output after each insertion. Store the result yet? At initial state, it should be appended to the stored list. Store the result yet? Yeah, we haven't stored the resulting array yet. That's what we're trying to figure out here. Why are we... Oh, so are we iterating over the back of our current array and taking that element? Are we popping? So let's go to the whiteboard here. Let's clear it up. So we have a list here with an element of 2, some string, an element of 1, some string. Yeah, I'm not really sure what it means to what is this resulting is happening here. Copy of sorted list. So we're going to, if we need to return a list of all of the current results, so we need a results list, but we need to sort over our current list is what it's currently what it's doing, because Okay, so if we want sorted, I'm trying to figure out why is it happening over the current list of pairs, right? It shows you the current one. It does a sort over the current one. It does a sort over the next one. Sort over the next one. So do we not want a sorted pairs, sorted list? Because we're trying to sort over our current list and return. Can we not just pop the value? Set I minus 1. I'm trying to just understand the problem, you guys. I'm not really focused on the actual code right now, so just, it's alright. Not in any rush here. I'm trying to understand it. Me just copying what you guys say into my thing doesn't really help at all. So we need definitely a list to house the results, right? But we don't need a sorted list, right? Because it looks like they're just iterating over the current lists. Or they're inserting and doing the insertions over the current list and updating that. So can we not pop off, reset our index back one place? So we have linked pairs for I, 1. Or we could have like a, I mean, we could have a result, we could have a sorted, you know, and we could append just every value from then forward, but that just wouldn't be very efficient. So we roll results is equal to a blank list. n is equal to the length of pairs. I is going to go over from 0 to n, so just to n. What do we want to do at I? Do we want to do anything in between I and j? Not sure. We gathered I, which will be our index value of so can we just make j a pointer one higher than I and then set all the values forward from there, or do we even need another for loop here? Can we just say from n, pop off the 0, what if we start from the back and pop off values, go forward, insert. But it wants you to insert from the forward here, insert banana first. Or, sorry, apple. Apple gets handled first. No worries, John. I appreciate you coming here. Work on this for about 15 more minutes, and then we can try again tomorrow. My girlfriend's just over right now, and I want to spend some time with her before she heads out for the week. So if we say for I in range of n, right, we're accessing all of the length of pairs, which is what our n is. We are going to say can we say while pairs at index 0, or pairs at index I rather, dot key is while pairs index I key is greater than pairs index I so can we initialize j here to equal I plus 1 and then go while pairs at index j dot key while that is greater, continually increase j. Can we just increase j? So while in this example we'll have apple and banana. So we'll get I is 0, so while pairs at index 0 key is greater than pairs at index 1, or 0 plus 1 is greater than continually, no, if it's greater than, we don't want to increase j, right? If it's less than, if it's greater than that value, if pairs index I key, which is going to be apple 5, if it's greater than this one, we want to move it over Um, you say I minus 1. Why is it I minus 1? Why would I want to be at negative first index? You want me to compare all values from the back forward? So if I is 2, j would be 1. If I is 2, if you did minus 1 here, j would be 1. So why would you compare a j value? Well, I mean, it would do the same thing, I guess. I'm doing the same comparisons whether it be I or j, so it's just the inverse of what you're saying. That's why you start at 1. Yeah, so if you start at oh, because if you start at 1, you would have j minus 1 to capture that first value. And your I would be your right pointer leading your j. So if I is 0, which is this value here, and j is I plus 1 is this value here, the key 5 will be greater than the key 2. See, I just haven't learned about insertion sort yet. I've never even seen it before, so this is why we're struggling here. It's okay. It's all fun. So j equals negative 1. So if I equals 0, while hmm, yeah, it's not terrible for never having seen this. I've literally never even seen insertion sort before ever. Like I said in CS50X, we've only learned about merge sort, selection sort, bubble sort. Okay, so we have a I don't really know if we make j negative 1. I don't know. Why would we make j negative 1? I don't get it because I is going to be 0 here, which is apple, which is this pair here. It has a value of 5. While it's greater than pairs j, which is 1 greater than the next value. Yeah, you start I from 1. Well, what's the difference? Is there any really difference of me starting I from 1 versus j from plus 1? It's just taking I and swapping in them. No? Yeah, I know it's 1 to that, man. But, I mean, I'm trying to think like trivially, is that no difference? That just makes my I and my j swap places. Hmm. If you guys are getting frustrated, please just understand that I've only been doing this for 6 months, teaching myself after my work. So I'm not in school, I'm not in class. I'm just doing this out of pure sheer will. You have a new item between I and I minus 1. Mahan, I know that you think you're making sense here, but I don't think you really are, my guy. Maybe to others, but at least not to me. Bro just reinforced himself in the third person. Yeah. I just take it at my pace. It's all right. There's no rush. So the length of pairs for either I in the range of 1 to n, if j is minus 1, right? What evaluation do we need to do, right? J equals I minus 1. Well, we need to see. I don't know the whole portion of. I mean, yeah, we can create a copy, but what do we do with the copy? So I'm trying to figure out is shoot. Toast Dev says this is so easy though. Then his next message says this is supposed to be hard. Okay, so for iterating over the honestly, John, no, I can't. That's the problem. I'm kind of going here with my a leg cut off. Like I said, I've never even seen insertion sort here before, so we're trying to learn it here on the fly. I think that's why people are frustrated here. All right. So if we start in this example here, we have index 0, 5 apple pair, right? Which is going to be, I is going to be here, and J is going to be here now. I just don't get how we I'm trying to the output portion. I think I need to solve smaller problems here. I need to Well, let's just stop focusing on the pair aspect for right now. Let's go to some practice problem here. And let's look here. Let's do like an example here. We have some list L here, which has values 2, 5, 7, 4, 3, 4, and 1, right? So if we want to do an insertion sort, we have def insertion sort on some n list. So the length, so I'll just say n is equal to the length of n here, and we have a results thing here. So let's just forget about the pairs for a second, and let's just try to solve this, trying to, with just numbers here. So we have the length of list. We're going to say toast dev. That's what being a beginner is all about, man. I think you're a little bit disconnected with what this is about, my friend. It's okay. It's all right, mate. It's just not in any rush here. So we have the length of the pairs, right? If we start for I in the range of 1 to n, what are we doing here? Right, we're accessing I, which is here, which is starting from 1 though, so 5 forward. Do we need a second loop? So if we have j, so if we have for j in range of is it -1 to I with a -1 step? All right. Cool. Hey Brian, welcome back. How are you doing, man? Yeah, I do this for like an hour and a half after my 9 to 5 job, man. I really think you're reading too much into this, my friend. It's really not that serious. You can do these things for fun, and it's okay if we don't get it. It's not okay. It's not competitive or anything. So now, if we're going up to I, so in the first case, I is going to be 1. J is going to go from -1 up from I. See, I think I'm just guessing this. So what do we need to do to this, though? So we need to save the first element. Can I try to do, like, implement this with just, like, like I said, with the sorted array? And just try to do it on top, in a new data set, rather than trying to do it over itself first. But I have to get going here in a second. Yeah, Brian, we've been grinding. Trying at least. Struggling. So we're gonna go from here. I'm gonna try my first approach and initially save the first value of n index 0 into here. That does that. We start from 1. So if we save 1 here, your message above, let me see, Mahan. I can't really, I think there's a bunch of messages here. You have a new item between I and I minus 1. You have a new item between of I and I minus 1. So if we save the first value inside, I'm gonna get rid of this for now. We'll just get rid of this now. Hey Wraith, welcome in. We're just having some fun here, learning some Python, trying to work through this practice problem. Yeah, so thanks for joining here. Just for fun, basically, learning problems. Okay. Not really being helpful anymore, my friend. Just kind of being toxic now. Okay, let's focus here. So I keep getting distracted by the chat here. Okay, so if we're starting from 1 forward here, we're saying but we don't really want to use a sorted list. I want to like take this value off and insert it into where it needs to go. So why can't I just pop this value? Why can't I pop the value? Because that shifts the thing down on the next iteration. It skips over the value. As previously meant. I just don't know how we're supposed to do it over the same list. Like, if I take I could insert so I say if this value is greater than these values, which is not. This is kind of a bad example. Let's put the 5 out front, and let's put 7 here, and let's put 2 here. Let me tell you something. At I equals n, you have j plus n plus 1 out of bounds. So either I or I minus 1, not I because it's the item. At I equals n, you have j equals n plus 1. So it's out of bounds. Okay, I get what you're saying. So either I has to be minus 1 or I minus 1. I get you. Come on, guys. Let's just chill. I don't know why we're like bickering and stuff. It's just completely not helpful at all. This is just about learning and having fun. Like, it's not about trying to one up people with what courses you've taken and stuff. Okay, so I get what you're saying, Mahan. For I in range of... Hmm. So if we're supposed to do it over the current list, though, that's what I'm having troubles with. So we start... So then we'll set j is equal to I minus 1, which means that j lags behind I. So then we don't need that because that'll just serve the purpose. So I is here on the first iteration. J is here. What do we want to evaluate? We don't want to swap these values. We want to do insertion. So if n at index, so I is here, j is here. If n at index j, which would be to 0, is greater than n at index I, which is the 7, we want to insert n at index j can we call n dot pop n at index no, because the whole point, all right, I'm not trying to swap adjacent values. I'm trying to find the place where it is. So let's just make this a 5 as well. So if we iterate over here, in this example, they're equal. So what needs to happen? Well, I needs to increase. So if they're equal, in this case, this specific example, this is j and this is I, right? So if the 5 is greater than if j is greater than I, index position, which is not, you're not going to do it. So in this case, we need to increase I again to evaluate for j. So do I need to push I forward? Sorry, I'm behind on the chat here. Yeah, we're doing insert Vance right now. I've never seen it before or even learned about it, so we're just trying it on the fly here. We're not doing too hot, but it's all right. I'm having fun at least. But yeah. So for J in, so we need to do another loop though, because we have to find at what point continue on at each iteration from I forward until it's sorted in range. So do we need to keep increasing I then? So while J is greater than or equal to 0, J is greater than or equal to 0. You want to find out where to insert. So while our J is greater than or equal to 0 and the val at J is greater than the val at I, you decrease till you find it. So while you want to find where to insert. So while our J is greater, while our J is greater or equal, so we'll say while J is greater than or equal to 0, which it is in this case, let's see, while J is greater than or equal to 0 and the val at J is greater than and n index J is greater than, so while J is 0 and n index J, which in this case is 5, is greater than n index I, right? If that's the case, we want to continually because I is our leading factor, which will stop at n while J trails. So at that point in time, it'll be sorted. So while J is greater than or equal to 0 and the value of J is greater than I, continually increase J. So that would be 5. That would be 2. Insert there. That gets pushed down. So we want it. And then after we break, we want to insert into the results and insert. At what index do we want to do? We want to insert at, so J will cross over our I until we meet a value that is less than I. So we'll see a 5, 5, 2. Okay, the 5 needs to go there. Insert at 1 higher than J. We want to insert n index I. All right. Just used some brain power there. Just exhausted my brain power. I need to refuel here with a nerd cluster. Okay. Um, decrease, not increase. We can't decrease j past 0. Oh, you're wanting to... Oh, you want to go backwards with j? While j is greater than 0? Decrease j? You want to decrease j because our condition is j is greater than or equal to 0, which starts at I minus 1. Now you need to shift, copy your previous values. So, yeah. We need to shift, copy your previous values. So n j plus 1 equals to n of j. Okay. After the insertion. Oh my gosh. Alright, you guys. So let's use our example. If you guys in the chat, if you guys have suggestions, try to use the example. It's easy for me to follow if you can reference the example here. It's hard by just using all these variables, j and I and stuff. So we're currently on, let's see. We're currently on 5, right? Our I starts on 1, which is 8. Okay? We're currently on 5. While j is greater than or equal to 0. So j is 0 here. And n at j is greater than or n at I. Well, that's not true here. It is less. So this current iteration is fine in this case. N of j plus 1. I can't call an index to j oh, you're talking about right here, before j minus 1. You're saying n at index j plus 1 equals to n at index j. In this case, it's fine. So you just copy all the values forward. N at index j plus 1, which is technically I, equals n at index j. Okay. So then, in my example here, though, this evaluates to not true. J is less than, So this evaluates to not true, so this does an insertion at j plus 1 for n of I. So it leaves the 8 there. So in the next iteration, it moves to I is 2 now. Or sorry, I is here, and j is here. Right? So now in this iteration, j is here. While j is greater than 0, it's 1. And n of j, which is 8, is greater than n of I, which is 2. That is true. We will go do this thing here. N of j plus 1, which is 2, equals to n of j n of j is 8. So you put 8 at this place. But then you're losing your 2 here. You're losing your 2 here, right? Yeah, then now. So you have to save value at I here. Next I. Before the second loop. Or just before this call. Right? So then we need to set so while j is greater than 0, which it is here, it's 1 in this case, and 8 is greater than 2, it will save the 8 in the I spot, and then decrease j by 1. Decrease j by 1. J is still greater than 0. J5 is still greater is not greater. So insert 5 here. Five, 8, 2, 3, 4, 1. 5, 8, 2, 3, 4, 1. Keeping track of the list and variables I and j. It might help to drop out the iterations. Keeping track of the list and variables I and j. See, I don't really know what's going on here because why are we overwriting and saving the previous value? But we need to insert I and DJ. All right, you guys. I gotta call it quits here for today. I'm gonna do some research on my own tomorrow regarding insertion sort and and see some examples, and then maybe we'll definitely take a shot at continuing this tomorrow. I just have never seen insertion sort before. I thought jumping into this problem, I thought that this was one of the ones we talked about in CS50X, but I guess it's not. So, anyways, I'll take some research on this and I'll look up some examples and see some stuff. But I'm going to spend some time here with my girlfriend, in the evening here and watch some shows before bed here. So I appreciate you guys joining me tonight. I'll be back tomorrow around 7 p.m. PST, and we'll continue working on this on DSA and Python, and then also into our personal project. I believe tomorrow, though, I also have scheduled for us to continue and watch the Harvard CS50X Week 4 lecture. Um, but I need to do more research on what actually insertion sort is. I get we're inserting at certain points, but I don't know the whole part that's tripping me up is the recreation of the elements preceding, from that point forward, in increasing index values. So yeah, I'll check out those videos you guys sent me. Appreciate you guys helping me out here and your patience. Like I do say, I am learning this. I'm just trying to provide an authentic point of view for what it's like to try these as a beginner. I I'm not expecting to get this right away. I'm not expecting you guys to, you know, this would be the greatest, most innovative approach ever. I'm really just trying to show what it's realistically like for some normal guy to try to learn this stuff on his own, without any like professors or any, just using the tools I have here at my disposal. I have to kind of use the chat. I can't really go ask like peers and stuff, or like, TAs for help and things along those lines. But we do have resources like AI we can help. I just don't want to, use it too much to, I do want to learn it and try to grind through it and get the satisfaction that way. But um, I'm gonna do some more research on it, and we'll come and tackle this one back tomorrow. But I just I keep feeling bad. We get stuck on these problems, and then we end up not getting to our other stuff that we want to get into, like our projects that we're writing, like the small business manager that we've been writing for the past few months. So, anyways, thank you guys so much for your help tonight. I really appreciate you guys, all of you guys. I know all you guys are just trying to help out there. So thank you truly for everyone that chatted today. You guys are all you guys come from a place of endearment. I know some people had some disagreements in the chat today, but everybody just comes from a place of trying to help at the end of the day. So that's at least how I take it, and I really really appreciate all of you guys just being here. So I started learning Python about 6 months ago. Yui, join my Discord. I'll chat with you more offline there, and you can ask me any questions there. Linked in my description. But yeah, I'll see you guys tomorrow. Thanks.